If you understand proportions, similarities of polygons almost come natural to us. Here are two important definitions. What are similar polygons? Similar polygons are two polygons or more than two polygons that have their corresponding angles being congruent and their corresponding sides being proportional. So notice the important keywords here. The corresponding angles are congruent and the corresponding sides are proportional. And the fraction in that proportion, when you calculate the corresponding sides, is called scale factor. So let's look at how we use these. Here is a diagram. Triangle ABC is similar to triangle DEF. And by the way, this is, notice that congruency, we use two wiggly things, and similarities, we use just one. So now because they are similar, we have to list all the pairs of congruent triangle. And by definition, all the corresponding angles have to be congruent in this polygon, in this triangle. So therefore, let's see, angle A should be congruent with angle D, right? Angle B should be congruent with angle E, and angle C is congruent with angle F. So that's A. Okay, now B, check the ratios of corresponding side length are equal. So again, it's not the side length are equal, it's the ratio of the corresponding sides. So then we have to calculate that ratio. So AB over DE would be 10 over 15, and BC over EF should be 8 over 12, and AC over DF, these are all corresponding sides, right? And so once you set this up and you simplify it, you should come up with exactly the same number here. And this 2/3 is what we call a scale factor. It's literally how much. So in other words, if you go from the bigger triangle DEF to the smaller triangle ABC, you have to go down by 1/3. That's what the scale factor means. So back to number 3. Write the ratios of the corresponding side length in a statement of proportionality. So we actually already did this. It's right here. It's AB over DE equals BC over EF equals AC over DF. That is right there. This is a D right here. So again, just want to highlight here. It says the statement of proportionality. Remember, proportionality is a equation that has two ratios, one ratio on each end, one fraction on each end. So so that gives us the hint that this is our statement of proportionality. Okay. Next example. Let me see if I can make this a little bit bigger. Oops. Really, there we go. All right, there we go. It's not perfect, but close enough. Find the scale factor. Determine whether the polygons are similar. And before I go any further, I know I need to find all the angles are congruent, corresponding angles are congruent, and all the corresponding sides are proportional. So if they are, write a similarity statement and find the scale factor of ABCD to JKLM. So step 1, identify pairs of congruent angles. This is all given from the diagram, as you can tell. So let's just list them out. I've got angle A being the right angle, is congruent to angle J. And then angle B is congruent to angle K because it has one of these squiggly points right here, right? And then angle C is congruent to angle L. Angle D is congruent to angle M. So great, half of the work is done. All the corresponding angles are congruent. So second step, we have to show that the corresponding side lengths are proportional. So that requires a little bit of calculation. So let's see, AB over JK. Make sure you find the corresponding side, correct corresponding side. And that will be 8 over 14. And then next I go BC over KL is 8 over 14. And DC over ML, that's 8 over 14 as well. And AD over JM is 12 over 21, right? So now if I simplify it, I should have, if I divide it by 2 in the numerator and denominator, so these three, these three are the same. This one I have to divide it by 3, cancel by 3, so I should have 4 on top and 7 at the bottom. So there's my scale factor, and I just proved that because the ratio 7/4, 4/7 are equal, the corresponding side lengths are proportional. So that's how I know. So if I have to write this statement, I can say ABCD, polygon ABCD is similar to JKLM. Hopefully you can write this squiggly thing a little better than I do. And the scale factor is right here, 7/4. Okay, so that's how we finish this example right here. In this example, you will see how much easier it gets now that you get more and more fluent with proportions. In this diagram, triangle BCD is similar to the bigger triangle RST. Find the value of x. It's exactly what we did earlier, except that we just carry the x until we're able to use algebra to solve it. So here again, because the triangles are similar, the corresponding side length have to be proportional. So, I should write this here. Let me use a different color. Proportional. And therefore BC, which is this vertical line here, over BCRS, and that should be the same as CD over ST, right? And you substitute the numbers into it, so it's 12 over 14 has to equal 13 over x, because ST is what we want to know right here, the big triangle here. You do your algebra, use cross product property, cross multiply. You should have 12x equals 24 times 13. And that should give you 312, and divided by 12 on both sides, you should have x to be 26. So it's exactly the same problem, just add a little bit of algebra in there. And here's a theorem, parameters of similar polygons. If two polygons are similar, then the ratio of their parameters is equal to the ratios of their corresponding side length. So what it is saying is that if you get the parameter, you add the side length all together and take their ratio of the two polygons. It should be the same as the scale factor that we were looking at. So in this example, KLMN is similar to PQRS. Then the parameter, you add the four sides together in the small polygon on the left, and then you add the sides together of the bigger polygon on the right. You take a ratio of that, and that should give you the same scale factor, KL over PQ, and that should also equal to LM over QR, whatever these side length are. It should be MN over RS, and it should be KN, oops, I'm sorry. Let's see if I can write it a little better. KN over PS. Okay, so that's really what it means. It's fairly intuitive. You can use properties of proportionality to prove this fairly easily, actually. Use the fourth one we learned in the last unit. Okay, here's a real-world example. A larger cement court is being poured for a basketball hoop in place of a smaller one. The court will be 20 feet wide and 25 feet long. So I drew in red ink the new court. You can see where I labeled, I should label all the sides. This side is 20 as well, and this side is 25 feet long. The old court was similar in shape, keyword similar in shape, but only 16 feet wide. So notice that I put the width right there, okay, 16. Now we're asked to find the scale factor of the new court to the old court. The only corresponding pair that I know of is right here. Let me use green. I know this is the corresponding sides, the side length, right? So that information alone is enough for me to calculate the scale factor. So the scale factor is 5 over 4. That's the easy thing. Now I have to find the parameters of the new court and the old court. So parameter of the new one is easier because all the information is given. I have the width, and I just need to multiply that by 2, and I have the length. So if you do your arithmetic, you should have 90 feet as the new court's parameter. Now for the old court, I don't know. I only know the width. I don't know the length. Now there are two ways of calculating it. One way, I'm not going to do it for you and see if you can do it yourself. This is a challenge. One way to do it is to use this information, the 25 feet length, and use the scale factor to calculate the actual length of the old court and then add them up together. So that's the first approach. The second approach is, in my opinion, slightly easier. If you recall from the theorem we just learned that because we know the scale factor is 5 over 4, and we came up with that scale factor by using the side length. But we also know by that theorem that scale factor also applies to the parameters. Because I don't know the parameter of the old court, I use x to represent that. And I simply solve for x. So if you do that, you will find the old court parameter is 72 feet. Okay? So there are different ways of solving it. It's unlikely that you will see the teacher specify exactly which property that you have to use to solve a problem. But all of these properties are related, and you can, once you understand one, you can prove the others. It's just a matter of practice and familiarity. I can't say that word. So, okay, so let's move on. Once you understand the importance of the scale factor, as we saw earlier, that not only applies to all the corresponding side length, but also it applies to the parameters of these similar polygons. It's a lot easier to understand this extension of that theorem. It says if two polygons are similar, then the ratio of any two corresponding length in the polygons is equal to the scale factor of the similar polygons. So let's see how this is used. Here we are, we have two similar triangles, FGH, which is the big one, and is similar to J right here. G is on top, K is there. So, so the big triangle is similar to the smaller triangle within it. And find the length of the altitude GL. It's asking us to find this. Oops, sorry. Let's see how I can get rid of that. Sorry, I made a mess there. There we go. Let me use a different color. GL. It's asking us to find GL. There's not much that's given directly about GL. So we have to use all the given information and derive the length of the altitude of GL. Here it gives us some hint here. First, find the scale factor. That's easy. FH is here. So FH would be, the corresponding length would be JK, right? So I should have 8 plus 8 over 5 plus 5. And that should give me 16 over 10, which comes out to be 8 over 5. So that's my scale factor. Then it says because the ratio of the length of the altitudes in similar triangles is equal to the scale factor, you can write the following proportion. GL, which is the big long altitude we're trying to find, over GM should also equal to the scale factor. And then you substitute GM is, we know is 14. So we just substitute 14 there. And then you cross multiply and do your arithmetic. You should arrive at the answer of 22.4. And here, obviously, you multiply each side by 14. And then and simplify it. Okay? So that's the answer. The length of GL is 22.4. So as you can tell, don't memorize these properties. Understand where they come from and follow them step by step. If you memorize them, it's way too much. I've been doing this for many years and I still haven't memorized any of them yet. But if you understand them, you can use them in a more dynamic manner that can help you to improve your understanding as well as your test scores. All right, guys, thank you.